Hi, this is an example problem from Chapter 12 on thermal expansion. Pause for a moment and read the question. Okay, so we have a track of a length of railroad track that has a certain length at a given temperature, 0 degrees Celsius. What happens when it heats up from 0 to 40 degrees Celsius? What's the new length? Let's go ahead and take a look here at equation that describes how the length of an object will change depending on the temperature change. And there's a coefficient of linear expansion here, alpha, which is specific for the material. Here we're looking at steel railroad track, so we're going to go ahead and use the value here, 12 times 10 to the minus 6. So let's go copy that information over. Delta L is equal to alpha L0 delta T, and in this case alpha for steel is equal to 12 times 10 to the minus 6, 1 per degree Celsius. All right, now we're looking at the length of the track on a hot day. And it's important to remember that this delta L here, this stands for the difference in length between the initial and final length. So this is L final minus L initial. And we can relate that to the temperature change, delta T, which is T final minus T initial. So what that means is that at the final temperature, this is your length, whereas at the initial temperature, this is your starting length. So if we write down the initial length, that's equal to 30.000 meters. And notice we keep a lot of decimal places here because the expansion is not a whole huge amount. And that's the length when the temperature is at 0 degrees Celsius. Now we're going to go ahead and try to figure out what is the length, the final length here, when the temperature is at 40 degrees Celsius. And 40 degrees Celsius is basically like a hot day during the summer in Fresno. So we're looking for this here, this final length. Now to calculate that, well, we can go ahead and just say the final length. Let's add the initial length to both sides. So it's going to be L0 plus alpha for steel times the initial length multiplied by the change in temperature. And we're going to go ahead and plug our numbers in and see what we get. So the initial length, 30.000 meters, plus alpha, 12 times 10 to the minus 6, 1 per degree Celsius, multiplied by the initial length, 30.000 meters, and then multiplied by, let's give ourselves a little bit of room here, multiplied by the difference between the final temperature, 40 degrees Celsius, and the initial temperature. And so calculation-wise, let's see, L final, it's going to be equal to 30.000 meters plus this remaining term here, which when we calculate comes out to 0.0144 meters. So that's the expansion. And when we add that together with the initial length, we get a total length of 30.014 meters. So essentially the tracks have expanded in length by 14 thousandths of a meter. Now it doesn't sound like a lot, but in fact, in the early days of railroad travel, they found out that that's too much. If you don't break these things up into small sections, you have longer sections, it's going to cause these things to buckle.